Alright, this is section 8.5. We're going to split the section up into two parts. So for this first part, we are going to study trapezoids, and that will also include isosceles trapezoids as well. So those are two shapes that you're going to have to be able to do diagram problems, graphing problems, and proofs. So let's start with the definition of a trapezoid. A trapezoid is a quadrilateral, so that means it's got four sides, of course, with exactly, make sure you underline that word like I am doing right now, has exactly one pair of parallel sides. So I draw a little picture of that. And remember, your trapezoid doesn't have to look just like this. But in my case, my two parallel sides are on the bottom and the top, and we refer to those as the bases. They're not the bases because they're the bottom and the top, they're the bases because they're the parallel sides. So in this other example here, even though the bases are on the sides, those are still referred to as the bases. The two sides that are not parallel to each other, we refer to those as the legs. Now sometimes those legs are going to be congruent to each other. And if they are, then we refer to that as an isosceles trapezoid. So what you see right now on that diagram is an isosceles trapezoid. Okay? The one below in red is not. That would just be a normal trapezoid. There are two theorems that you should be familiar with from this section, and both of them only work with isosceles trapezoids. So please make sure that you emphasize that in your notes, that these are only with isosceles trapezoids. The first one says that in an isosceles trapezoid, both pair of base angles are congruent. Both pair of base angles are congruent. Now what are the base angles? Well, the base angles are the two angles that are on each base. And so what we're saying is, if you have your two angles at the bottom of this shape here, they'll be congruent to each other, and then the two at the top would also be congruent. Those are your base angles. Remember, this is only in an isosceles trapezoid that this relationship is going to hold true. The other theorem is that also in an isosceles trapezoid, the diagonals, so if you drew a diagonal in from one corner to the opposite corner, that those diagonals will also be congruent. So that line and that line. So in an isosceles trapezoid, you actually have a lot of different relationships that are going on. We'll talk more about those in just a second. Another term that goes with trapezoids is the mid-segment of a trapezoid. Now I don't have this written down here, but the mid-segment is the segment that connects the midpoints of the two legs. So you might want to jot that down somewhere. It connects the midpoints of the two legs. And what is unusual or interesting or special about it is that it will be parallel to the two bases, and this is in any trapezoid, not just an isosceles one, but in any trapezoid, parallel to the two bases, and if you add the lengths of the two bases together, it will be half of that sum. So here's a picture that illustrates that. Alright, so it connects the two midpoints, so I really, right now, I know that these little pieces right here, as part of the legs, those are congruent. And I do know that those are all parallel now. And if I take the length of AB and I add it to the length of CD, half of that total is going to be the length of EF. Again, just a reminder, those lengths there are congruent to each other. So let's look at some practice problems here. Alright, we'll try a couple diagram problems, and then we'll move to a graphing problem. So first diagram problem we'll look at is one with a mid-segment. And for each of these, I'd like you to be able to, once you write the problem down, pause the video and try to figure things out first before I show you how to do it. In this problem, you know that one base is 4x minus 10, and the other base, that letter is wrong there, and that shouldn't be CD. That really should be YV. And that last one down there should be ZR. And so YV, the mid-segment, is 13, and ZR is 3x plus 8. I'd like you to solve for x and also find those lengths. Good time to push pause on the video right about now. Alright, well hopefully you were able to solve this. If not, here's what it looks like. I'm going to add my two bases together, 4x minus 10 and 3x plus 8. I'm going to divide that by 2, and that's going to equal 13. If I'm combining like terms, my 4x and 3x give me 7x. My negative 10 and positive 8 gives me negative 2. I'm going to cross multiply. When I work all this out, I get x equals 4. And so I can plug that back in and see if it really does work out like it should. So 4 times 4 is 16 minus 10 is 6. 3 times 4 is 12 plus 8 is 20. If I add those two together, 6 plus 20 is 26 divided by 2 is 13. That's how we use the mid-segment in a diagram problem. Here's a diagram problem that you're a little more familiar with. And this is the one you definitely need to be able to do when you're all done with this section today. So I am drawing for you right now an isosceles trapezoid. So ABCD is an isosceles trapezoid. And I'm giving you 80 degrees for that little angle, and then 7 for AD, and CD is 12. Again, remember, this is an isosceles trapezoid. That's not written down anywhere. Find the lengths and the angles. Good time to push pause right now. Alright, hopefully you're able to find some stuff. I'm going to go through it as if I was you trying to find everything. I'm going to start with the law of sines using triangle DAC. So I set that up as sine of 80 over 12 equals the sine of that little angle C over 7. Do my work on my calculator, do some cross multiplying. I figure out that that angle is just a little over 35 degrees. So just for convenience sake, I'm going to call it 35. I know that 80 and 35 is 115, and so I can subtract that from 180 to find the rest of that triangle. So angle D over there, the big angle, is 65 degrees. Since I know that base angles are congruent, I know that both of those angles there are 65 degrees. Again, I know that those legs are congruent in an isosceles trapezoid. I can do some subtracting here. I can find a whole bunch of angles right now. I know those are alternate interior angles up at the top, so I know those are both going to be 35 degrees as well. I also know that since I have parallel lines, that those are consecutive interior angles, and so the 115 and the 65, those are supplementary to each other. There's a whole bunch of angle relationships in this problem if you're paying attention here. I also know that that angle right there is 35 degrees, so that makes that little triangle DEC isosceles. And eventually I'll figure out that the top one is also isosceles as well. So those are some things you might want to jot down, that in an isosceles trapezoid, you've got a pair of isosceles triangles, and then you also have a pair of congruent triangles, but not both at the same time. One pair will be isosceles but different sizes, and then the other pair will be congruent to each other. So I can find all of my different angle measurements in this problem just by working around and using triangle sum theorem and vertical angles and all those different things. To finish up some lengths, I'm going to go back to law of sines again now. Now I'm looking at the little triangle, like triangle AED. And I can do something like sine of 70 over 7 equals the sine of 30 over AE. I can also do sine of 70 over 7 equals the sine of 80 over DE. That should be DE, not AE. That's a mistake. Make sure you got that one right, please. Sine of 80 over DE. So again, going to my calculator, doing a little work, I find out that AE is 3.7, which also makes the other side of that isosceles triangle the same. And if I do work on the bottom isosceles triangle, the side that's opposite the 80-degree angle, that ends up being 7.3 along with the other one. So those are all of my lengths and sides with the exception of the top one. I still have to find length AB, but again, that's another law of sines problem. Sine of 110 over AB equals the sine of 35 over 3.7. So in this problem here, we have a lot of law of sines going on, a lot of angle relationships. Hopefully you can solve all of those. When I do the work for this one, I end up getting about 6.1 for length AB. Alright, so here's a graphing problem now. How are you going to do a graphing problem and fit this into your method so far for classifying various quadrilaterals? Alright, again, I wouldn't ask you to change a whole lot as you go through this. So if you have A is 0, 0, and B is 0, 3, and C is 2, 4, and D is 4, 2. I'd like you to classify this quadrilateral as specifically as possible. Anytime you want to push pause right now and stop and try to figure out what you know first before I do it for you, that would be great. Alright, hopefully you've done that already. For me, I'm going to start with slope like I always do. Find the slope of my opposite sides. In this case, when I find the slope of AB and CD, they do not have the same slopes. Alright, so they're not parallel to each other. Now before, I'd stop at this point because if it doesn't have parallel sides, then it's none of the shapes that we've looked at already. But I've got to keep going now because this could be a trapezoid if it only has one pair of parallel sides. And when I work out BC and AD, I get 1/2, and I get 2 over 4, which if I reduce that 2 over 4 is going to reduce to 1/2. And so those are my parallel sides there. BC and AD are my parallel bases. So that tells me I have a trapezoid. But if it's a trapezoid, remember, I can still classify it a little bit more specifically if it's isosceles. And so the question is, what will you do to figure that out? For me, I think the only way you can do this right now is with distance formula. And I'm going to look at the distances of the legs, the two sides that were not parallel. Alright, so those two distances both end up equaling the square root of 9. Or, I'm sorry, one is the square root of 9 and one's the square root of 8. So those are not congruent to each other. And so if they're not congruent, then it's not an isosceles trapezoid. And so my final answer, ABCD, is just a trapezoid. I hope that makes sense to you. I hope that you understand how to graph that. If not, make sure you practice that in your homework. Speaking of homework, your homework assignment for tonight is page 546. And we're going to do problems 3 through, let's do 3 through 16 and 25 through 32. Alright, hope this makes sense. We'll see you next time.